Okay, so today we are going to do direct variation. Direct variation is just linear functions, okay? It's just linear functions, though, that have a b value of 0, okay? So direct variation is a specific relationship in which there is a constant ratio between two values, and our ratio is going to be y over x. That's your constant ratio between two variables, y over x. This constant of variation, the variable is k. We use k for our constant of variation. Direct variation equations can be written in the form y equals kx. Okay, y equals kx. So again, it's just a linear function who doesn't have a b value. So your k is just essentially your what? Your slope, your m. Okay? So direct variation is just a linear function who has a b value of 0. Okay? So we are going to identify the constant of variation of the ordered pairs below, then write a direct variation equation to represent the relationship. Okay, so the way we find our k is we are going to do y, which is 4, over x, which is 1. What's 4 over 1? 4. Okay, then let's try it for the next ordered pair. 8 over 2, y over x, because that's how you find your k, or your constant of variation. So what's 8 over 2? 4. And then 12 over 3, which is 4. And then 16 over 4, and you get 4. So, do I have a constant of variation? Do I get the same value each time when I do y over x? Yes, I do. Okay. So, yes, this is an example of direct variation. So then the way I write my equation is just y equals, what's my k? 4 x. And that's your direct variation equation. Good? Okay, next. All you're doing is do y over x. So y over x. What is 3 over negative 6? Negative 1/2. Okay. 2 over negative 4. Okay, so this one's a little tricky because 0 over 0. Okay, so we're going to kind of skip that one. So let's go to the last one, negative 1 over 2, which is what? Negative 1/2. So guys, could I multiply 0 by negative 1/2 and still get 0? Yeah. 0 times negative 1/2 is 0. This just means it goes through the what? Origin. All direct variation problems must go through the origin because your b has to be 0. So does this still follow my direct variation? Do I have a constant of variation? Yes, so what would my equation be? Good? Okay, next one. Let's do y over x. What is negative 8 over negative 12? 3/4. Positive 3/4 because of negative over negative, positive. Negative 4 over negative 6. Wait, 3/4? This should be 2/3. Not 3/4. 2/3. Okay, what's negative 4 over negative 6? Do I need to try 0 over 0? No, because that's just the origin. That's telling me, yes, this goes through the origin. Okay, so then 2 over 3, which is 2/3. So do I get the same constant of variation every time? Yes, so is this an example of direct variation? Yes, so I get y equals, what's my k? 2/3 times x. Okay, I want you all to try number 4 on your own. Try number 4 on your own. Okay, so is this an example of direct variation, guys? Yes, what's your equation? Y equals negative 3x. Very good. We get negative 3 every time we do our ratio of y over x. We good? We okay with telling from a table if something is an example of direct variation? Okay, now we're going to go to equations. Equations are going to be written in the form y equals k times x. If it doesn't say y equals, you might have to solve for y to get it to say y equals. Okay, so we are going to say yes or no. Is this an example of direct variation? If it's a yes, we're going to say what the k is. Okay, so is this in the form y equals kx? Yes, so is this an example of direct variation? Yes, what's the k? Good. Next one, y equals k times x. Is this an example of direct variation? Yes. What's the k? Negative 4 over 5. Y equals kx. Is this an example of direct variation? No, because there's no x. So no. What kind of line would that be, guys? Horizontal line. It would not be going through the origin, so it cannot be direct variation. Okay? Number 8. This doesn't say y equals, so what do we need to do? Solve for y. What am I going to do to get y by itself? Divide both sides by 2, and we get y equals 5 over 2x. Is this an example of direct variation? Yes. What is the k? And again, k is just the same thing as slope. Okay? Do I have a b value? So my b is 0 because we go through the origin for direct variation. Very good. Y equals kx. Is this in direct variation form? No. Is it already solved for y? Why is this not direct variation? You have a y-intercept that's not 0. You have a b. So this is no. Is this an example of direct variation? Yes. What's the k? Negative 1. Don't include the x. Just like when we identify our slopes, you don't include the x. When you're identifying your k, your constant of variation, don't include the x. Your slope and your constant of variation is x's coefficient. Don't include x when we're stating what it is. Okay, number 11. Is this in y equals form? Is it solved for y? Nope, so we have to solve it for y. What am I going to do? Divide both sides by 2, and we get y equals what? 1/2 what? X. Very good. Is that an example of direct variation?
Yes.
Yes. There's no plus or minus number out to the side. What's my k?
1/2.
1/2. Okay, next one. Solve this for y. What am I going to do? Minus 4x on both sides. Very good. And I get 2y equals. Are they like terms? No, so you can't combine them, so it just becomes negative 4x plus 6. You can't add or subtract terms that are not like terms. Keep your y circled. What am I going to do to get y by itself? Divide everything by 2, and we get y equals. Is this an example of direct variation? No, because you have a b value. Okay. Last one, draw a line through the equals, circle y. What am I going to do to get y by itself? And we get y equals negative 5x. Is this an example of direct variation? Yes. Good job. What's my k? Negative 5. We good? Okay, now we're going to go to some direct variation from graphs. In order to say yes from a graph, it must go through the origin. So that's what I'm going to start with. Does number 14 go through the origin? Yes, so is this an example of direct variation? Yes. Okay, now in order to find the k is just your slope, so rise over run. Okay, so how much do I rise? Up 3, very good. And how much do I run? So what's my k? Positive or negative? Positive, because my slope is positive. Good? Next, does this one go through the origin? No. So is this an example of direct variation? No. Doesn't go through the origin. It has a b value of 1, 2, 3, 4. So it's not direct variation. Good? Number 16. Does 16 go through the origin? Yes, so yes, this is an example of direct variation. Okay. Calculate your rise. How much do I rise? 1. How much do I run? To the left, which is negative 4. Very good. So what's my k? Negative 1/4. Okay, number 17. Is this an example of direct variation? Does it go through the origin? Yes. Okay. Then we need to find our slope. 1, 2, 3. I go up 3. 1, 2, 3. I go right 3. So what's my slope or my constant of variation? K equals 1. 3 over 3 is 1. Are we good with telling direct variation from a graph? Okay. Now we are going to find some missing values. It says if the following ordered pairs represent direct variation, find the missing value. Okay. So I'm going to set up my problems as y over x. Okay, y over x. Because that's your constant of variation, right? So this is just going to be a proportion. Looking at my first situation, or my first part of the sentence, it says if y is negative 18 and x is 3. Set up your fraction. Negative 18 over 3 equals, find x when y is 30. So what am I going to write on the right side? 30 over, do I know x? No, so 30 over, if you don't know it, can you replace x with a number if you don't know the value of x? So just 30 over x. We need to find x. Are we okay with that? How do you solve a proportion? How do you solve a fraction equaling a fraction? What did we say? I heard somebody say it. Cross multiply. Okay, so 18 times x, sorry, negative 18 times x is negative 18x is equal to 3 times 30, which is 90. Are we good with that? Now we need to solve for x. What am I going to do? By negative 18 on both sides. And we get x equals negative 5. Done. Good? The biggest thing with these guys, make sure you're pairing up the correct values. If y is negative 18, x is 3. Those have to go together into a fraction. Find x when y is 30. So x and 30 need to go together in a fraction. Okay, you have to make sure you have the correct values paired together. Okay. Okay, so next, if y is 80 and x is 32, set up your fraction, y over x. So 80 over 32 equals, say it again, 100 over x. I don't know the x value. So then I am going to cross multiply. 80 times x and 32 times 100, 3200. What do I do? By. Good job. And we get x equals 40. Good? Okay, next, 24. If y is 10 and x is negative 4, set up your fraction, y over x. So 10 over negative 4 equals what? X over 12? Y over 12. Y goes on top. This time I know the x value, I don't know the y value. So what should I do? Cross multiply. So I get negative 4y equals 120. I need y by itself. What am I going to do? Divide by what? Negative 4. Very good. And we get y equals negative 30. Okay, I want you all to try the last one on your own. Try 25 on your own. Okay, so what did we get for our y value, guys? 5? Very good. So you do negative 7 over negative 28 equals y over 20. Cross multiply and you get negative 28y equals negative 140. Divide both sides by negative 28 and we get y equals 5. Questions? Guys, you can also check yourself once you get your value. Okay? Go to your calculator and do negative 7 divided by negative 28. And that should be the same as y over 20, which we just found y to be 5, so 5 over 20. Do they give you the same values? Yes, because you should have the same constant of variation, the same k value. Good? Okay, so we are done for today.